Next, we will discuss the measurement of energy. Measurement communication. This is an extremely important step to ensure everybody is on the same page. First, we need to determine what exactly is under consideration. Let's use electricity as an example. We need to determine the quantity of how much to be communicated. Will we be measuring from the main substations, or will we be measuring further down the line? We need to choose a reference that is repeatable, agreed upon, and understood by all parties. It's no use producing measurements that cannot be used. We would then just be wasting time. We would have to ensure that when measurements are taken, that they are consistent and reliable, and everybody understands where they are taken, what has been taken, and how much. We therefore have a quantitative or magnitude, and we have a qualitative, a physical quantity in units, for example, kilograms per meter cubed or kilowatt hours. The measurement of thermal energy. Temperature is a measure of microscopic movement of matter and reflect the average energy of particles. Therefore, agreed upon references have already been put in place. For example, water freezes at 0 degrees Celsius. Water boils at 100 degrees Celsius. Absolute zero is minus 273.16 degrees Celsius or 0 Kelvin. These are all valid only when atmospheric pressure is at sea level of 101.32 kilopascals. Next, we discuss the measurement of potential energy. The main areas of interest is a position, chemical composition, pressure, and electrical energies. When taking the position into consideration, it's a mass that can fall a height. So, having the ground as a zero level and the mass 10 meters above ground, therefore we can calculate the amount of potential energy available based on the position of the object. Chemical energy. We can calculate the type and number of chemical energy bonds that can potentially break and release stored energy. Chemical energy can either emit or be exothermic, where heat is produced, or require energy, where endothermic or heat is added in order to achieve the desired chemical reaction. Pressure is a measure of energy pushing upon surroundings. Standard units of pressure is pascals. Below we can see various standard forms of pressure that has already been predefined. Electrical energy, we can measure and calculate energy pushing electrons flow. We can measure and calculate the voltage, current, and resistance. Voltage is a force pushing or driving the flow of electrons and measured in volts. Current is the actual flow of electrons in amperes. And resistance is the resistance to flow of the electrons measured in ohms. To measure energy, equations must have dimensional consistency. They need to balance numerically on both sides of the equal sign. They need to balance in units, cancel out units, and use brackets wherever needed. A simple example is shown in this slide where we would like to achieve kilojoules. We have kilowatt hours, which is 2000, and we have 3600 kilojoules per kilowatt hours. This example focuses on converting kilowatt hours into kilojoules. We can see that kilowatt hours will eventually cancel out, and we will be left only with kilojoules. Let's look at the difference between energy and power. The energy expended is a work done in joules through applying a force of 1 Newton through a distance of 1 meter. Power is the rate of energy conversion and takes into account the time for the process to take place. This is measured in watts. Watts can be converted into joules per second, where the time interval comes into play. Calories, on the other hand, can be defined as a nutritional energy or heat present in food, the chemical energy that's waiting to be released. Calories are the metric units of heat. It is the energy to raise the temperature of 1 gram of water 1 degree Celsius. Calories are normally converted or commonly use the unit joules. British thermal units, or BTU, as you will often see on your aircon units, is the energy required to raise 1 pound of water from 63 degrees Fahrenheit to 64 degrees Fahrenheit. The conversion factors. 1 calorie is equal to 4.184 joules. 1 BTU is equal to 1055.1 joules. In this slide, base units can be seen for the SI system. With the base units, we can derive further units. For example, area, meter squared, volume is meter cubed, density is kilograms per meter cubed, or specific volume is the inverse of density, where it's meter cubed per kilogram. We can also determine multiples and submultiples when working with bigger or smaller numbers to make them more understandable. In summary, what is energy? Energy is the ability to do work. Energy exists in useful and not useful forms. Energy can be converted several times between forms. Energy conversion always increases a non-useful quantity as there will always be energy losses present. The total energy needs to be considered, meaning macro and micro energy. Energy can cross a thermodynamic boundary in two different forms. Organized, where macroscopic energy comes into play, work on mechanical energy, and disorganized, microscopic, heat or thermal energy.